we're going to kind of review it in a little bit. Solve by factor, I'm going to kind of go through these fairly fast. Bringing over the 9x to the other side, minus 9x minus 36 is going to be equal to 0. Two numbers that multiply to give you negative 36 adds up to give you negative 9, negative 12, and positive 3. So because we have these solutions, we can get x is equal to 12 and x is equal to negative 3. So these would be our two of them that we want to be able to see here. Okay. The one to the right, by completing the square, I'm going to go ahead and leave a little space out for it. Plus a space, 21, plus a space. Whatever we do to one side, we got to make sure we do to the other. We're going to take our b term, negative 6, divide that by 2 and square it. Negative 6 divided by 2 squared is 9. So we're going to add 9 to one side. We got to add 9 to the other. This is going to give us a factor term of x minus 3, x minus 3. If you want to put it all together, you're more than welcome to do that already. I'm just showing it for the people that need it. We're going to go ahead and combine our groups to get x minus 3 squared is equal to 30. We want to solve this simple quadratic by taking the square root to both sides. So we're going to get x minus 3 is equal to plus or minus the square root of 30. And then we want to take it the extra step and by adding 3. So 3 plus the square root, plus or minus the square root of 30. This is our answer. Yes.
Is there a way that we simplify that down to get like?
Can we simplify 30 down? Perfect roots would be what? 1, 4, 9. Yeah, doesn't work out.
Like for the last question that we had, or in the notes we had like one where we simplified
We couldn't.
all the way, but we had square root of 20 and we brought it down to 2 rad 5. Do we have to do that on the test?
I'm not going to be too picky on it. I'm not going to be too picky. For those that are going to plan to take calculus, your teachers will require. So just keep that in mind. To me, it's one more step. It's an easy simplification step, but I'm not going to kill you guys over it. You're not going to be deducted points. I'll ask you to simplify it if need be. Simplify all radicals if that's going to occur. If I don't have it, you can leave it as it. Okay, so leave it. The bottom one is, so I'm going to clear this a little bit just so I can have more room. I'm going to go ahead and bring everything to one side. I think it can be factored because 2, negative 6, and 20 are have a GCF. And that's the easiest way to go about this. We always want to see if we can factor first. I'm going to pull out a 2 and see what that does. Get minus 3x, minus 10. Is there any two numbers that multiply to give you negative 10 and adds up to give you negative 3? Negative 5 and 2. So that would be the fastest way to do this. You could use completing the square. It'll give you the same thing. And you're going to get a perfect root for that. It just depends on what you want to do. So the 2 in here doesn't really matter. It's a multiple on the outside, so that really doesn't change up our equation. If we solve for the interior portions, x minus 5 is going to give us x plus 5 if we set it equal to 0. And our last one here, x plus 2 will be x minus 2. Using the zero product property, this is what we want to be able to see here. So this is probably a really good problem to do on Friday's quiz. What I want to be able to see here first is I got to convert the left-hand side into one term. So this is going to be very helpful. Some of you guys like seeing it like this. If you stack them better, it becomes a lot nicer for you guys to actually solve. What is the least common denominator between those two fractions? 5x squared. So the top is going to remain the same. What do we multiply the bottom by to get that 5x squared? By 5. So now that we have those, we can actually add the top two and then keep the bottom. So we're going to get 3x plus 8 all over 5x squared. So that's going to be replaced up here into our term. 5x squared is equal to 3 over 5x squared. Now with this here, what's probably the easiest way to solve this out? Cross multiply, by all means. Cross multiply on these. We're going to get 15x squared is equal to, I'm just going to distribute this already, 15x cubed plus 40x squared. I'm going to bring everything to one side. So I'm going to subtract out 15x squared to both sides. 15 minus 40 is what? What is it? 25? Okay. From here, you might get confused just because we haven't really been solving out problems like this. We can still do it. Do we have a GCF with this? What would be our GCF? 5x squared. So we're going to go ahead and get, what is this going to turn into? 3x. And then what? 5x plus 5. All right, 25. So this is going to look nice because we actually have all we have to really do now from here is because we have it factored in factored terms, this becomes a factor. So if I really wanted to show you guys, 5x squared is equal to 0. What is x equal to? 0. Anything times 0 is 0. So this one works out really nice. And then if we set this other part equal to 0, we're going to get x is equal to negative 5/3. So all that complication kind of comes down, looks nice. I like 2 and 3. I wouldn't put number 4 on there for you guys. So I like 2 and 3, but I don't think I'd put number 4 on there for Friday's quiz. Okay. So don't worry about it. Okay. I'm going to erase some of this because I got to do the other problems. That takes care of 1. So 13 here. All it's asking us to do is complete the square. So 13, we'll do 13 first. I know we got 9. Don't worry about it. In this case, our CTS, completing the square term, is going to take negative 26, divide it by 2, and square it. We're going to divide it by 2 to get negative 13 squared, or just 169. So this is where that 169 would go. So that was the first part of the solution. The second part of it was being able to rewrite it in terms of factors. So minus, let's change up the color. Let's do lime green. This will be z minus 13 and then z plus 13, or the factor term z minus 13 squared. So this was the other part to that. I think it was written like this for it. Cool? Yes. Oh, it should be minus. Sorry. Yes, you're right. Thank you. Do over jealous of myself. Okay. So that's how we want to be able to do that. Number 9 here, let me cross that out. It says solve by factoring. So it's definitely not in the order that we want it to be in. We want to put it in ax squared plus bx plus c. So I'm going to bring everything to the other side. It's going to be x squared minus 10x plus 21 is equal to 0. So we should be able to factor that out. Two numbers that multiply to give you 21 but adds up to give you 10. -7, -3. 0. When we set these equal to 0, we're going to get x is equal to 7. And then if we set the other one, we're going to get x is equal to 3. Those are two numbers. I'm going to do 19 on the side because I have a little bit more room on this one. 19 is going to be 8n squared is equal to -2n plus 8. If, again, we want to use a quadratic equation that's up there, we just got to rewrite it in terms like this. So 8n squared plus 2n plus 8. I'm just kidding. It'll be -8. This is going to be our a, b, and c. We got to be able to plug it into the equation. X is equal to -b plus or minus the square root of b squared minus 4 times a times c all over 2a. And all we want to be able to do with that is simplify out and solve. So it would be x is equal to -2 plus or minus square root of 4. What is that? 4 minus, it would be 4 plus the quantity 32 times 8. You guys get 260? Is that right or wrong? Yep. This can actually be reduced down to x is equal to -2. Oh, I'm going to mess this up. Write this on the other side. The 260 can be simplified out. It says it can be simplified to 2 radical, so -2 plus or minus 2 radical 65 all over 16. And all I did is they pulled out a 2. So they reduced everything by 2 to get -1 plus or minus square root of 65 all over 8. So these two are exactly the same. So if you got that, it's pretty close. If you got that, you're good too. Cool beans? Cool beans. Okay. That was 19. 22 is, or 19, what was 19? 22 is doing the same thing essentially. So we have 22 and 25. 22, we're doing the same processes, which is 10p squared minus 6 is equal to -2p. I'm going to bring that 2p to the other side. The person that requested this, are we okay not doing this, or do you still want me to do it? I forgot who asked me to. Can I just plug it in? And if you plugged it in correctly, you're good. X is equal to -b plus or minus the square root of b squared minus 4ac all over 2a. If you plug that in there, you're good. Use your calculator to simplify that out. Good? Okay. I believe you guys should be able to do that by now. If you need more help, let me know. 25, our last one here. We're looking at the discriminant. We're looking at the discriminant term, which happens to be b squared minus 4ac. It comes from the quadratic equation, the inside term of the quadratic. If d is less than 0, it is imaginary. imaginary. I'll just put imagine. If d is equal to 0, how many solutions do we have? 1. And if d is greater than 0, we have 2. I'll put 2 as a word. It's a word. It's a word. So our discriminant okay, it's not in the ax plus by form, so I'm going to bring everything over to one side. We got to make sure we're having everything on one side if we're going to use a discriminant and even solving. If we plug our values in, we are going to get b squared, so 3 squared minus 4 times a, which is going to be my negative 10, times c, which is going to be 10, negative 10. If we look at the discriminant, this is going to be 9 minus, what is it, 40 times 10, or 400? Negative 391. So it's definitely less than 0. So how many solutions do we have? 2 imaginary. Or just imaginary. We'll just put imagine. Imaginary. No real solution. Imaginary numbers, it basically comes out to be that we have a square root of negative 391. And we can't have, underneath the square root, we can't have any negatives, so technically it fits underneath the complex coordinate system, which we don't really do. Okay, we don't really do all that. Okay, there we go. Let's close this down. Let's open it up. Yo.
I got 16 right there. I got this minus 6. Like I'm positive 10 and negative 6.
So slight mistake probably when you're solving. Probably a quick little boo-boo. Okay, copy this down. Yep, just this only page. This is the only page we have. Yeah, I just gave you the paper just to have, so you don't have to copy down the word problems. Yeah. We want to read the problem carefully more than once if we need to, identify the variable, draw a diagram, and make a table, set up the equation. We're going to kind of jump around problems, and so we're going to do one a little bit differently. We're going to work on problem number 5 first, so we're going to look at metal problems, and then kind of move on from there. So copy that down. So we're actually going to do 5 and 6 first before we kind of move on. And then we're going to look at 9 and 10. So I'm going to skip the first chemistry problems because I don't like how they came out. Read the problem, identify the variable, draw the diagram and make a table or make a table, set up the equation and solve and check your answer. So copy this down. You don't, hold on, don't wait. Don't copy this down. We're just going to work with mixture problems. So I want you guys to kind of have an idea what we're doing with these. So I was going to do more different types, but we're going to kind of move on. Mixtures. These are a bunch of mixtures. And what we really say is we have a solution of 1, the solution of 2, and then we have our final solution. And what we're going to get from this is we're going to get percentages of each solution and how much we need to make of each one of them. And we're going to need to add up the 2 solutions together. And we're going to be given an amount. I think these are easier looking at this way than creating a table. We want to be able to situate these in such a way that we can find the ratios of one solution, or if we have a final solution going backwards. The notes we want to make on this is given one solution and final, we're going to have difference. We're going to have to find the difference of one of the solutions. If we're given 2 solutions, we're going to need to find the sum. And we also want to note that percents to decimal conversion. So we want to be able to change those around. Okay, we got to convert that. In this case, our first problem will be problem number 5. How many milligrams of metal containing 90% platinum must be combined with 9 milligrams of pure platinum to form an alloy containing 96. So we're going to look at changing those percentages into decimals. If you don't have a calculator out, I highly recommend you pull a calculator out. Your cell phone can definitely do it as long as you flip it on its side so it gives you more of the scientific functions to convert. If you need a calculator over there, calculators over there will work out the same. And we're going to follow this. The chemistry problems, the metal problems, and the juice problems all stem from the same idea. The other final thing we want to also note is whenever we say pure, means 100%. Like the number 1, how many quarts of a 60% alcohol solution with 11 quarts of pure water? It's containing 100% water. There's no solution in there. It's just 100% water. So we want to be able to look at the differences between those. Okay. So let's go ahead and look at our examples here. So we're going to jump around. We're going to skip to 5 and 6 just because I think they're a little bit more easier to grasp. Okay. Now, how many milligrams of metal containing 90% platinum must be combined with 9 milligrams of pure platinum to form an alloy? So my biggest thing that I would kind of write these out is I'd write out the solutions. So that we have solution number 1, solution 2, you can abbreviate them, S1, S2, and then we have F for final solution. And we want to be able to see how they're all relating. You can create the actual containers themselves so that we can see the solutions and how they're changing, and looking at how much we're looking at the final grouping. We're going to add up our two solutions to equal a final solution. We have the first one containing 90%. How many milligrams of a metal containing 90% platinum? So we do have 90% in our first solution. Contained with 9 milligrams of pure platinum. So we have 100% of pure platinum, which is 9 milligrams, to form an alloy. So we're looking at our final alloy of 96% platinum. So our variable has to be what first solution we're going to be creating. Now, because we're given solution 1 and solution 2, we're trying to find solution F, the sum of these two, the sum of the two is what we're going to be able to add into it. So this is probably the key part of this, is we're looking at adding this portion to it. The sum of them, if we're trying to give them, if we're given 1 and 2 solution, we're trying to find the final, we're going to be given that. Okay, so you want to see how all these are related. The differences and sums are going to be kind of important. We have our solution set here, so let's go ahead and multiply these out. I'm going to convert 90 into 0.90. We don't have to have that 0, but just so you guys can recognize that we have 90% solution to that one, is going to be added to a 1.00 times 9, because we have 9 milligrams of that. And then we have the 0.96 times x plus 9. So this is how we want to be able to look at them. Try to do at least 3 or 4 of them today for you guys, and then I'll give you guys, I think I only gave my class only 3 of them tonight, just for you guys to try. And all we're going to do here is just simplify out. We're going to go ahead and multiply out our terms. Make sure that you guys keep the negatives in. We have plus 9 is equal to 0.96 plus 9 times 0.96 is going to give us 8.64. I'm going to move my values over, so 9 minus 8.64 is going to give me 0.36 on one side. If I subtract out 90 from the other, I'm going to get 0.06. X is going to be equal to 0.36. I think it's going to give us 6. So in this case, we need to have a 6 milligrams containing the first solution. Calling out our variables, we got to be able to see it that way. In this case, we would have 6 mgs, 6 milligrams of our first solution at 90% needs to be added with 100% of platinum in order for us to get that. The 0.06 divided by 0.36. I subtracted out, I just subtracted. Subtracted 90, subtracted 80. Yeah. So we're just solving this as basic, multi-step solving systems, or solving, not systems, but solving in order for us to simplify it. Metallurgist needs to make a 6 kilogram of alloy containing 15% platinum. So we're trying, that's our final solution to this. We're looking at our final solution. So they're telling us our final. So solution 1, solution 2, and our final. So he's given us some information about it. So I'm going to kind of abbreviate this a little bit nicer. So S1, solution 2, and then our final. He tells us a metallurgist needs to make. So we're making it. So we're creating a 15% platinum with 6 kilograms solution. So he's given us the last part of it. So because we're given the final one, we need to be able to find the differences. So we're looking at two different values. So he is going to use, he's going to melt and combine one metal. So our first solution is at 65%, and we'll just give it a X value with another metal containing 5%. Now, this is where we want to be able to write this stuff in, and we're going to look at our ending two terms, and we're going to be able to subtract them. So we're going to take, it'll be whatever 6 minus X is, because we can only have up to 6 kilograms of our metal alloy, right? So right, because like, look at the notes that I just said, right? If you're given the final solution and one solution, we're going to look at the differences, right? Just the way that we wrote it. In all the stuff that we were given here, this is what we were given. We knew this, right? Because it tells us 6 kilograms of alloy containing 50%, and it tells us he's combining it with one other solution at 65%. So it's giving us at least those two. We can start out with the variable, right? So we're given one solution idea, and we're given the final. So we said if we have one solution and a final, we're going to look for the differences. So the difference is going to come in 6 minus X. In the first problem we did here, we were given solution number 1 and solution number 2. We're forming an alloy. So we're going to look for the sum for the last one. Does that make sense? So that's what you want to be able to recognize, is if it's giving you kind of one of them, and we're going to kind of work our way through this, okay? So this is what we got to be able to see. And it's going to be 6 minus X because we can have at most 6 kilograms, right? So if we take the difference of the two, it's going to be 6. We're going to have our solution, so 0.65 X plus 0.05 times 6 minus X is equal to 0.15 times 6. And the more we do this, and I'm doing the first couple examples with you, but the next one hopefully we'll be able to determine, are we going to subtract them or we're going to add up the bases? Simplifying. 0.05 times 6 is going to give us 3 minus 0.05x, 1.5 times 6, 15% of 6 is going to be 0.9. Yes.
Multiplying the 0.05 by 6, we all got us
0.3. I got 0.3 too. So I just read it wrong. Not bad. Not bad. Just seeing if you're paying attention. That's all. I'm going to get combined like terms. I'm going to get 0.06x plus 0.3. 0.0 or 0.60. Gotta hate decimals. I hate decimals. 0.9 minus 0.3. We're going to get 0.6. If we divide them out, we're just going to get 1. Look at how nice that came out to be. Go figure. So our first alloy at 65% had been here. So we're looking at our first alloy there. So 1 kg at 65% strength. And then if we plug the other one into here, we're going to get how many? 5 kilograms at 5% strength. Yeah, at 5%. So somewhat different. Let's go ahead and look at the next set of problems. I'll kind of hold up on the chemistry ones because I think you guys are like reliving bad memories. Let's not live bad memories. Let's not do that. Okay, let's look at number 9 for us. Let's look at number 9. Try to set up the equations. Let's see if you guys can set up the solutions, and we'll convene back in about a minute. Okay, think about how they're set up. See if you can just set them up and see if you have the right stuff. How much of fruit punch A needs to be mixed, of 18%. Fruit punch needs to be mixed with 6 liters of grape juice to create a mixture containing 80% fruit juice. So think about that. And we're looking at 100%, because I'm guessing it's not giving us the other one. So 6 liters of 100% grape juice is going to be at 80% of our contained mixture. Think about that. See if we can write out the equation. I'm making a boo-boo somewhere. Don't like that.
Is the first solution always X?
Not necessarily. I mean, yeah, you can make them X. Yeah, yeah. The solution can always be X. So let's see if we set this up. Solution 1, solution 2, and our final solution. We're gonna have fruit juice at. We need to find out how much of brand A is going to be at 40%. So we have a brand A at 40% solution. Is going to mix with 6 liters of grape juice. So we're given 6 liters at 100% concentration to create a mixture, to create a final mixture of 80%. So what should we write for the grouping of this? I heard it. Someone said it. X plus 6. Ooh, I made a boo-boo. Let me solve this out to make sure I'm teaching you guys this right, which I'm pretty sure I am, but I digress. X plus 6. Yes. What do we get for our solution? Three liters. Huh? The work for, you want me to show you all the work? Oh, you guys are so needy. This is going to be 0.4, so we have a couple minutes left. 0.4x plus 1.00 times 6 is going to be equal to 0.80 x plus 6. Can you guys get it from there? Or do you want me to kind of simplify out one more step? 0.6. Is this okay? How did I do today? How did we do today? Good. Is it a little easier than last year? No? Plus 4.8. And then we're going to get 2.8 and I believe 1.2. I'm sorry, I'm trying to wing it, man. 1.8, yeah, 1.8, and this is going to be point. I'm just kidding. 1.2 and then 0.4. 4. And then we're going to get 3. Do me a favor. Circle 10, 11, and try 3. 10, 11, and 3. Just 3 of them today. Just 3. It's the same concept. It's the same concept. 10, 11, and 3. Oh, we did metal ones, right? How about we do this? 7, 11, and... do these ones. Do these ones because these are more what we did. 7, 8, and 11. 7, 8, and 11. 7, 8, and 11. Yeah, scrap 3.
I know my fault with the 7 that I forgot to turn on Friday. So mom's gonna ask me about it, so when we get a chance to use them,
By Friday?
yeah, because she's like,
I'll put them in Friday.
Practice.
Put them in Friday.
All right, cool.
Yeah, put them in Friday.